Chapter 11 File Handling. In this chapter, we will explore how to access, identify, and manipulate files and directories on the hard disk through Java programs. Throughout the chapter, we will focus on input or output processing and file handling. We will use the most common classes available in java.io package and few classes of java.util package. Let us begin the discussion with an overview of files and directories. Understanding computer files. Storage devices of a computer system can be broadly classified into two categories: volatile storage and non-volatile storage. Volatile storage is temporary. Values stored in variables are lost when a computer is shut down. A Java program that stores a value in a variable uses random access memory, that is RAM. Apart from variables, objects and their references are generally stored in RAM. Once the program terminates or the computer shut down, the data is lost. Non-volatile storage is permanent storage. Data is not lost when a computer loses power. When a Java program is saved on a disk, we are using permanent storage. A computer file is a collection of data stored on a non-volatile device. Files exist on permanent storage devices such as hard disks, USB drives, optical disks, and compact disks. Data stored in file is often called persistent data. Files can be further classified broadly into two categories: text files and binary files. Text files contain data that can be read in a text editor because the data has been encoded using a scheme such as ASCII or Unicode. Text files can be data files that contains facts, such as payroll file that contains employee numbers, names, and salaries. Or some text files can be program files or application files that store software instructions. Files created through editors like gedit, vi, pico are examples of text files. They may have extensions like txt, java, or c. Binary files contain data that has not been encoded as text. Their contents are in binary format, which means the data is accessed in terms of bytes. Some example extensions of binary files are JPEG, MP3, and class. Java language supports various operations that can be performed on file or on directories. Few operations that can be performed on files using Java programs are listed below. Determining the path of a file or a directory. Opening a file. Writing to a file. Reading from a file. Closing a file. Deleting a file. Querying the attributes of a file. Java provides built-in classes that contain methods to help us with these tasks. These classes are present in java.io package. Java uses the concepts of streams and it provides two different categories of Java classes to perform I/O operations on bytes and characters. A detailed discussion of reading from files and writing to files will be covered in the subsequent sections. File class in Java. The java.io.file class encapsulates information about the properties of a file or a directory. File class can be used to access attributes of files and directories. We can create or rename or delete a file or a directory. We can also access the attributes of a file like its permissions, length of a file, or last modification time. The creation of a file object that belongs to file class does not imply that the file or directory exists. A file object encapsulates a path name or reference to a physical file or a directory on the hard disk. There are nearly 30 methods of file class that can be used to perform various operations on a file or a directory. However, file class does not provide any method to read from a file or write into a file. There are several stream classes to perform such operations. So let us begin our study of few widely used constructors and methods of the file class. Constructors of file class. By using the file class, We can create a reference to any file by providing its absolute path in string format or by providing the relative path. The file class provides following constructors to refer a file or a directory. File in bracket string path, file in bracket string directory underscore path, comma, string file underscore name. File in bracket file directory, comma, string file underscore name. Let us take an example for the above mentioned constructors. In Linux, inverted comma, passwd file present in inverted comma /etc inverted comma directory stores the information of the users existing in the system. Suppose we want to display its attributes, then its Java file object can be created using three ways as mentioned below. By specifying the path as file obj is equal to new file in bracket inverted comma /etc /passwd inverted comma bracket over colon. By specifying directory and file name as two separate arguments. File obj is equal to new file in bracket inverted comma /etc inverted comma inverted comma passwd inverted comma bracket over colon. By using the reference to directory encapsulated in dirobj object, file dirobj is equal to new file in bracket inverted comma /etc inverted comma bracket over colon. File obj is equal to new file in bracket dirobj comma double inverted comma passwd double inverted comma bracket over colon. Methods of file class. The table summarizes few widely used methods of file class. Method Boolean exists bracket description returns true if the file or directory exists, otherwise returns false. Method Boolean is file bracket description returns true if the file exists, otherwise returns false. Method Boolean is directory bracket description returns true if the directory exists, otherwise returns false. Method Boolean is hidden bracket description returns true if the file or directory is hidden. Method string get absolute path bracket description returns the absolute path of the file or directory. Method string get name bracket description returns the name of the file or directory referred by the object. Method string get path bracket description returns the path to the file or directory. Method long length bracket description returns the number of bytes in that file. Method string square bracket list bracket description returns the name of files and directories in a directory. Method file square bracket list files bracket description returns an array of abstract path names denoting the files in the directory. Let us now try to understand a program that lists the file names in a given directory. After creating an object of file class that refers to a particular directory, we can use the list bracket method to list all the files present in that directory. The program given in code listing demonstrates the listing of file present in double inverted comma /home /akash /programs /files double inverted comma directory. In the program, we have used a variable to count the number of files and directories for a given directory. An array list of files of the file class is used to store the file objects present in the directory. The output of code listing is shown in figure. Note: the above code lists files and directories present in the /home /akash programs /file directory. You may use appropriate file name and path to see the output. Introduction to streams. Till now, we haven't seen how to modify a file or display the contents of a file. To perform such operations, we need to understand the concept of streams. Java uses stream classes to carry out read and write operations on files. We have already studied the types of devices used for input and output. For instance, keyboard is an input device while monitor is an output device. Hard disk can be classified as both input and output device, as we can store and read data from the files. There are various devices available in the market from different manufacturers and different capabilities. For example, hard disks are manufactured by various companies and come with different storage capacities like 500 GB or 1 TB. Apart from this, hard disk can be connected using different cables like USB or SATA. However, a Java programmer does not need to worry about the technical details like type of hard disk or its capacity while developing a program to perform read or write operations over the files. This is possible because Java language provides functionality of streams. A stream is an abstract representation of an input or output device that is used as a source or destination for data. We can visualize a stream as a sequence of bytes that flows into program or that flows out of our program. We can write data or read data using streams. When we write data to stream, the stream is called an output stream. The output stream can transfer data from the program to a file on a hard disk or a monitor or to some other computer over the network. An input stream is used to read data from an external device to the program. It can transfer data from keyboard or from the file on a hard disk to the program. The main reason for using streams for input or output operations is to make our program independent of the devices involved. Two advantages of streams are: programmer does not need to worry about the technical details of the device. The program can work for a variety of input or output devices without any changes to the source code. Stream classes in Java. To understand byte streams and character streams, let us first try to differentiate between character and byte representation. Let us take an example of number 5. We can represent the number in two different ways as shown in table. Representation. Character 5. Particulars: ASCII value 5 3. Binary representation 00 11 01 01. Representation: binary number 5. Particulars: binary value 5. Binary representation 00 00 01 01. A character is generally stored using ASCII or Unicode format, but when it is used for calculation purpose, its binary value is meaningful. Let us take one more example. The statement int I is equal to 32 declares I as an integer type variable that stores number 32. However, 32 can be represented as two separate characters, 3 and 2. The character representation is advisable when we write sentences like "human beings have 32 teeth," where we are not performing any kind of operations over the number. But when we apply numerical calculations, we use data types like int, float or double that allows us to store the numbers in binary format. Java supports two types of streams: byte stream and character stream. Streams that transfer data in the form of bytes to the file or devices are known as byte stream or binary stream. The files that are created using ByteStream are known as binary files. Suppose if we wish to store variables like integer, double or boolean into a file, then we must use binary files. Binary files can also be used to store arrays or objects. Similarly, text files and program codes are created using character stream. They can be opened in text editors like VI or SCITE. Java provides two sets of classes, character stream class and binary stream class. Character stream classes present in java.io package deal with the character or text data, while ByteStream classes present in java.io package deal with binary data. Figure shows the classification of stream classes. Java streams can be classified into two basic types, namely input stream and output stream. An input stream reads data from the source, that is, file, keyboard, while the output stream writes data to the destination, that is, file, output device. The java.io package contains a collection of stream classes that support reading and writing in a file. To use these classes, a program needs to import the java.io package. Although there are many classes to perform character and byte operations, we will discuss the most widely used classes. Discussion of each class belonging to java.io package is out of the scope for this textbook. Character stream classes. Character stream classes are a group of classes available in java.io package. They can be used to read and write 16-bit Unicode characters. Character stream classes can be further classified into reader and writer classes. Reader classes are a group of classes designed to read characters from files. The writer classes are a group of classes designed to write characters into a file. Figure shows the hierarchy of character stream classes. As seen in the figure, java.io.reader class and java.io.writer class are inherited from the object class. They are abstract classes, that is, classes that cannot be used to create an object and come with set of methods to be implemented by its subclasses. Input stream reader and buffered reader are the subclass of reader class. FileReader class is the subclass of input stream reader class. Similarly, output stream writer, buffered writer, and print writer are the subclasses of writer class. FileWriter class is the subclass of output stream writer class. Now, let us understand the constructor and methods of some of the above mentioned classes. A detailed description of methods, constructors can be obtained from the online Java documentation at http://docs.oracle.com/java.se/6/docs/api/. Writer classes. Writer class is the base class for writing a character stream. The abstract writer class defines the functionality that is available for all character output streams. We will be using the FileWriter class in our program to perform write operations. The method of writer class can throw IO exception. An IO exception occurs when there is a failed IO operation. IO exception is a checked exception, so we must take care of it, otherwise there will be a compiling error. Table lists few of the methods of writer class. These methods are used by its subclasses. Method void close bracket description closes the stream. Method void write in bracket int c description writes the lower 16 bits of C to the stream. Method void writes in bracket string s description writes string s to the stream. The output stream writer class extends writer class. It converts stream of characters to a stream of bytes. The FileWriter class extends output stream writer and output characters to a file. Some of its constructors are FileWriter in bracket string file path bracket over throws IO exception, FileWriter in bracket file obj bracket over throws IO exception, FileWriter in bracket string file path comma boolean append bracket over throws IO exception. In the above constructors, the parameter file path is the full path name of a file and file obj is a file class object that describes the file. In the last constructor, if append is true, characters are appended to the end of file. Otherwise, the existing contents of the file are overwritten. For example, we can create an object of FileWriter as shown below. FileWriter FW object is equal to new FileWriter in bracket double inverted comma slash java slash files slash carefile1 dot txt double inverted comma bracket over colon. Let us take an example that illustrates how to write to a file. We will assume that the files are saved in the working directory. The code listing shows how to create a file carefile1.txt that does not exist. Further, we write few lines into that file using the write bracket method. Methods like write bracket and close bracket used in this program are inherited from the writer class. Output of the code listing is shown in figure. After execution of the program, we use the cat command to display contents within the newly created file carefile1.txt. It is important to close the stream object after writing to a file is accomplished. Open files consume system resources and depending on the file mode, other programs may not be able to access them. It's important to close files as soon as the operations are over. Reader classes. Reader class is the base class for reading a character stream. The abstract reader class defines the functionality that is available for all character input streams. We will be using the FileReader class in our program to perform read operations. Table lists few of the methods of reader class. These methods are used by its subclasses. Method void close bracket description closes the stream. Method int read bracket description reads next available character from the stream. It returns double inverted comma -1 to indicate the end of stream. The InputStream class extends reader class. It converts a stream of bytes to a stream of characters. The FileReader class extends InputStream class and reads characters from a file. Some of its constructors are FileReader in bracket string file path bracket over throws file not found exception, FileReader in bracket file obj bracket over throws file not found exception. We can create an object of FileReader as shown below. FileReader fr object is equal to new FileReader in bracket double inverted comma slash java slash files slash char file1 dot txt double inverted comma bracket over colon. In the program shown in code listing, we attempted to write to a file double inverted comma char file1 dot txt double inverted comma. Now let us write a program that reads from the file that we have already created. The program shown in code listing reads data from the file using read bracket method of FileReader class. This read method is inherited from the reader class. Figure shows the output of code listing. Here it can be noticed that the execution of program displays the output on the screen. It displays all the contents of file inverted comma char file1.txt double inverted comma. There is a special symbol to identify end of file, that is EOF. File reading from a file, program must identify that the file has ended. However, the program reads from input stream, so Java read bracket method returns double inverted comma -1 double inverted comma to identify the end of data in the stream. Byte stream classes. Till now, we have seen how to process characters using java.io package. Most of the real-life applications require numeric calculations like storing the details of inventory in a file and calculating the costs involved, or like storing the employee details and their salaries in a file. For such kind of processing, Java provides set of binary streams and their associated classes. The FileInputStream and FileOutputStream classes in the java.io package give us the ability to read and write bytes from and into any files in the disk. These classes are the subclasses of InputStream and OutputStream classes. FileOutputStream. The FileOutputStream is a subclass of OutputStream and is used to write bytes to the file or some output stream. To use this class and its methods, first we need to create a file object. Then we could use the write method derived from the abstract class OutputStream to write byte data into a file. Few widely used methods of FileOutputStream classes are shown in table. Method: void close bracket description closes this file output stream and releases any system resources associated with the stream. Method: void write in bracket int b description writes the specified byte to this file output stream. Method: void write in bracket byte square bracket b description writes b dot length bytes from the specified byte array to this file output stream. The constructors of file output stream can accept either a string containing the path to the file location or an object of the file class. Let us see few constructors that are normally used. File output stream in bracket string name bracket over throws file not found exception, or file output stream in bracket file bracket over throws file not found exception. Examples of creating instances of file output stream are as shown below. File output stream FOS object is equal to new file output stream in bracket double inverted comma slash home slash akash slash myfile dot txt double inverted comma bracket over colon. Alternatively, we can also use file FOBJ is equal to new file in bracket double inverted comma slash home slash akash slash myfile dot txt double inverted comma bracket over colon. File output stream FOS object is equal to new file output stream in bracket FOBJ bracket over semicolon. The above listed constructors can throw file not found exception if the file name refers to directory rather than a regular file, file does not exist, or file cannot be opened for some reason. File input stream. File input stream is a subclass of input stream and is generally used to read byte data from the files. It provides set of methods to perform write operations over the files as shown in table. Method void close bracket description closes this file input stream and releases any system resources associated with the stream. Method int read bracket description reads a byte of data from this input stream. Method int read bracket byte in square bracket b bracket over description reads up to b dot length bytes of data from this input stream into an array of bytes. Let us now see a program that uses the above described classes to perform write and read operations over a file as shown in code listing. The program shown in code listing writes a string to a file, double inverted comma, binary file dot dat, double inverted comma. Later it creates an object of FileInputStream to read the data from the same file and display it on the screen. We must note that in the above program, typecasting is applied to convert integer to character after read operation is performed. Note: to observe the difference between text file and binary file, open the files creating using the programs given in code listing. Processing input from keyboard. In this section, let us explore the different ways to input the data to Java program through the keyboard. As we know, a program can get input of data from live interaction through keyboard or GUI, or it may take input as command line arguments or from files. Although there are many classes that facilitate the input from keyboard, here we will discuss two of the most widely used technique, using scanner class of java.util package and using the console class of java.io package. Scanner class. Scanner class belongs to the java.util package. It provides various methods to read input from the keyboard or from the file. A special feature of this class is that it breaks the input string into tokens, that is words, using a delimiter. Whitespace is the default delimiter. Each token can be of different type. For example, a string like double inverted comma India dash 1947 double inverted comma can be read as double inverted comma string dash int double inverted comma values. Let us explore the constructor and few methods of the scanner class. Scanner in bracket string str. Scanner in bracket input stream is object. Scanner in bracket file f object bracket over throws file not found exception. A scanner object can be created from a string, file object or input stream object. For instance, we may use the constructor in the following way to read from a file and keyboard respectively. Scanner file input is equal to new scanner in bracket new file in bracket double inverted comma students dot dat double inverted comma bracket over colon. Scanner kb input is equal to new scanner in bracket system dot in bracket over colon. Some of the important methods available with the scanner class are listed in table. Method void close bracket description closes the scanner. Method string next bracket description returns the next token. Method boolean has next bracket description returns true if there is a token in input. Method int next int bracket description scans the next token of the input as int. Method float next float bracket description scans the next token of the input as float. Method string next line bracket description scans the next token of the input as line. Let us now see a program that reads two numbers interactively from the user and displays the addition of those two numbers. Code listing shows the program. In the code listing, we have created an object of scanner class. The constructor of scanner class accepts double inverted comma system.in double inverted comma as an argument so that it reads from the standard input, that is keyboard. Both the numbers are scanned as integer numbers using the next int bracket method of the scanner class. Figure shows the output of the program. Scanner class can also be used to read from a file. Let us see an example where we use the scanner class to read the data from a file that contains information about few students. It is assumed that the file students.dat already exists. It contains 5 fields: student underscore no, comma, student underscore name, comma, marks of 3 subjects. The format and data of the file students.dat is as shown below. 1. Akash 45, 65, 55. 2. Badal 10, 20, 30. 3. Zakir 45, 40, 60. 4. David 65, 50, 75. We will write a program as shown in code listing to read the data of each student and perform operations like calculating the total marks and displaying them on the output. The output of the program is displayed on the monitor as shown in figure. Console class. In the previous example, we used the scanner class to read user input. Apart from the scanner class, there is another class java.io.console which can be used to get the input from the keyboard. We use this class especially when the input is to be typed in hidden form, that is, characters must not be echoed on screen. The console class provides a method for reading password. When reading the password, the user input will be hidden or not shown in the console screen, and it will return an array of character as the return type. The console class belongs to java.io package. Few widely used methods of console class are listed in table. Methods: string readLine, bracket, description. This method reads a single line of text from the console. Methods: char, square bracket, read password, bracket, description. This method reads a password or passphrase from the console with echoing disabled. Methods: console printf, in bracket, strings format, comma, object args. Description. This method is used to write a formatted string to this console's output stream using the specified format string and argument. The program shown in code listing demonstrates the use of console class to read username and password. Further, it validates whether the username and password are correct or not. The output of the program is shown in figure. We have used 2 attempts to input the username and password. In the first attempt, the username is false, and that is why we use invalid username message. In the second attempt, we entered the correct username and password. The program can be extended to read list of users and match their passwords from a file in the presence of multi-user environment. Apart from various classes discussed in this chapter, Java provides classes to store and retrieve objects using files. It also provides classes and methods to access a file randomly. Till now, we have seen the methods that perform sequential operations. However, there are classes which allow us to directly jump to nth record instead of accessing it sequentially. Discussion of these classes being out of scope for this text, we leave it to the students for exploring various other interesting features of java.io package.